Mr. Harmless here, and I'm going to do some practice now with these right triangles with altitudes and showing that they are similar triangles. So let's do that first with just being able to list these off, okay? So there's 3 triangles here, so I'm going to draw those 3 triangles. And they don't have to be perfect, but I try to emphasize which side is the longer, which side is the smaller. Then we have the little triangle. Okay, so this large triangle, the big triangle that overlaps everything, notice the right angle is right where Q is at. So I know this has got to be Q. This shorter leg is up to R, so I know R is there. Leave me Q and R, and then P is right there. Okay. This second one, that's this one on this side right here. Notice its right angles where the S is at. Down the shorter leg is Q, so Q has got to be here. And then P is the last point. And then this triangle on the right here, the smallest one, the right angle is right where S is at. R is down the shorter side. And then Q is the other point of that triangle. So when I ask you to identify the similar triangles in the diagram, then sketch them so the corresponding sides and angles have the same orientation. That's what it's talking about. The same orientation means they're all sitting the same way. The triangles that are now similar would be RQT, similar to triangle QST, similar to triangle RSQ. Okay. If you have any other questions, let me know. I am going to go ahead and do this next one here, but you may want to pause and try this, whether it's on this one or another one similar to that. Try that, see if it makes sense. See if you can do this without watching, and let me know if you're stuck. But let's go ahead and do some examples then where you're going to use this knowledge to solve for something. So for example, in this question right here, okay, one of the things that I do when I'm doing these is I just take a triangle that I know a lot of numbers for. Like, so for example, this largest triangle here, right triangle, okay? I'm sitting it like this. I'm going to draw that a little bit better. For me, it helps to get as close as possible to what it looks like. Okay, so in this triangle, that's the big one. It's facing the other direction, but notice 9 and 12. And this hypotenuse is 15. Now I'm going to pick this smaller triangle. This one, let's go with this one on this side right here. See that one? So this triangle right here, and I'm going to flip it around so it's sitting the same way, facing the same way as the larger one. So in this one, notice the 2 legs here, the longer of the 2 legs is X. That would be here. And I don't know what this is because it's just part of this 15, but I do know that this hypotenuse is 9. So once you do that, you go, okay, well now I can set up a proportion because that's what similar means. It means the sides are proportional. So I can set up a proportion using these numbers. The numbers that match up, that correspond to each other, can be set up in a ratio. So the 9 is matched up with this 15, and the X is matched up with the 12. Okay. So then all you have to do is solve this. You can cross multiply to solve. So I'm going to do the 9 times the 12 divided by 15 equals X. If you can, sometimes it's good. Let me undo to get rid of those arrows. Sometimes it's good to simplify first. So for example, the 9 and the 15, I know 3 goes into both of those. So 3 times 12 is 36. 36 divided by 5 is going to be this side here. So X equals 36 divided by 5. 7 1/5. Okay. So that's kind of the idea of what you're going to do. You're going to find the similar triangles, set them up so that you can find the ratio, and then solve from there.